All right, first thing I want you to do is bring in some graph paper. Now, I'm going to do it this way. You're probably going to use your iPad and do it that way. But get some graph paper up. Now, this test has a lot of graphing on it. So let's talk. If I asked you to graph this and you were like, I don't even know what that looks like. You're right, you wouldn't know what that looks like. But could you figure out what it looks like by graphing a bunch of points? You could. But don't even do it. I just want you to think about what you would do. What's the first step? Like, know what the parent function is? No, you don't know what the parent function is. So how can you graph anything? X, Y chart. Would you please don't graph this. Just find me a few points that you know work. Like when I put in 2, I got this. Yes, there are fractions involved. That's okay. Would you please put in 0? And I want you to see that one, and I want you to think it through. Some kids think that means that, oh, that one's impossible. Not true. When you put in 0, what do you get? 0. So if I put in a 0 here and a 0 here, I get 0 over 1, which is 0. If it had a 0 on the bottom, that'd be the problem. Okay, so 0, 0 is on this graph. Even if I don't know what it looks like, I know 0, 0 is on it. Do you get, like, if you had just graphed it and your graph had come out like here or something, and it had weird asymptotes or whatever, you'd be like, ooh, I know this point has to be on it, and then it isn't on my graph. It's a great way to check if you're doing things right. Or to graph one where you just don't know what that shape is. All right, so let's, somebody else tell me another point you stuck in. Yes? And I put in a 1, and you get 1 over 2, which is 1/2. 1 comma 1/2. So 0, 0, 1 comma over 1 up 1/2. Okay. Yes? Negative 1. What'd you get when you put in negative 1? Okay, I agree. Negative 1 over, what's the bottom? Ooh, wait a minute. Negative 1 over 0 is a thing, but what is that thing? It's an asymptote. That's that fancy word. If there's a 0 on the bottom, it doesn't exist. There must be an asymptote there. At negative 1, there's an asymptote. Okay. So this is a tricky one. We wouldn't have anything this hard, but my point was that if you just get a bunch of dots, and if I keep on getting dots and they start doing this, you're going to be like, oh, looks like it's like a parabola here. And you get another couple dots, and they're like here, here, here. Like, oh, it's like almost like a x to the third graph. You don't need to know the function. You need to be able to make an XY chart. All right, this one, I hope you know this function. Do you know what they look like in the first place? Square root function. I'm getting crickets. There's one chirping in the back. Come on. You know what a square root function looks like? Draw it with your finger in the air. All right, good. So it's hard to say what this looks like, but everybody was doing this. Yeah, you're right. Okay. Now this one, would you agree it's not your normal square root function? Some stuff has happened, right? Let's kind of try to piece together what kind of has happened. Would you agree that this seems like it's saying move to the left 1? And then do you get there's also a 2 in here, which is some kind of, was a horizontal or vertical thing? Horizontal. And 2 means, well, normally it means make it bigger, but on the inside it means make it smaller horizontally. So, yeah, I'm not sure exactly what's going to happen to this guy. So what do you think I'm going to make next? XY chart. Everybody make an XY chart. I think you'll find at least 3 points on it. The other points, other than that, will probably go off the graph. Find at least 3 points on this XY chart. This is not super easy. Pay attention. Follow along as best you can. So your first step is you try putting in like 0 and see what happens. Just try it. And then, actually, that worked out pretty good, didn't it? Because it's the square root of 0 plus 1, which is 1. So square root of 1, which is what? 1. 0, comma 1 is on my graph. Put a dot on your graph. Now find a few more points. And I think you'll get an idea where this thing is. Don't forget you can put in fractions if you want. Like if it helps you in some way to put in x equals 2.5, you could do that. Who's found another good x? Yes, ma'am. Put in a 4. Awesome. Tell me why that's better than like putting in something else. The square root works out perfect because it ends up being 9 there, and square root of 9 is 3. And again, if some kid thought that square root of 9 was actually 3 and negative 3 because they misunderstood their teacher in the past, you'd get 2 answers here. But that's not right. The square root of 9 is just one thing. It's 3. Okay, so 4 comma 3, I'm going to go over 4 and up 3. Do you get, this is starting to look a little bit rampish. No, that's kind of what it should do. If it's like a normal one, like this, like, okay, that's not normal. If it was down here, do you get it? They started at 0 and you couldn't put in negative numbers. Let's see what happens if I put in a negative number. If I put in a negative number here, do you get it's going to end up being square root of a negative? Okay, so yeah, that's another reason I can tell this is the square root function. Now, I'm not a tyrant. You have to put in 5 points if you can. You can't on this one. It's going to go off the graph. I don't know. Did anybody find another one that was actually on the graph perfectly? Yes. Ooh, I like it. Why did you put in 1 and 1/2? So this part was equal to 4. So let me, exactly, yes. So what you just said is, if I wanted this thing to be 4, so it worked out nice, then I just needed 2x plus 1 to equal 4. See what I mean? It's a little equation that you could solve. And he figured out that that came out to 5 over 2. No, 3 over 2, sorry. So he put in 3 over 2, also known as 1.5, and he got out 4, so then the square root of that 4 came out to 2. So 1.5 over 1.5 and up 2. Look at that. It's right on our... Oh, I screwed up. Over 1.5 and up 2. It's even more on our line. Perfect. Over 1.5 up 2. Okay. Do you think you could have graphed that? Can you find points and then play connect the dots? It's not that hard. Yes, ma'am. Yes, it is. That's a good question. Maybe it goes further left and we don't know it. Do you get what I'm saying? Is there anything that says I can't put in like 1/2? Or sorry, negative 1/2. Let's check that. If I put in negative 1/2 into this function, everybody try it. Put in negative 1/2 in the green function and see what happens. If you put in negative 1/2, did you get 0? That wasn't like imaginary. Square root of 0 is 0, so negative 1/2, 0. So it actually touches right there and starts up. I didn't have the beginning of my graph. I'm glad you caught that. Now if I go further left, it will not work. And yeah, you're right. It hadn't moved up 1. I mean, and that's a great way to check it. You looked at it and said, it seems like the graph I have has moved up 1. So you could check 1 more x and then, oh, there's another point there. Good catch. All right, here's another one. Start with that. And make a sketch first. Everybody just sketch it. I don't want you to do the XY chart and get the dots. Just sketch where you think that thing should be. Like, I know it's a V shape. and then mutate it from there and say, I think this is what should happen. I think it should move here, and I think it should stretch this way, and I think it kind of looks like that. Check with the kid next to you and see if yours is kind of in a similar spot to theirs. And I know the stretches are kind of hard to figure out. But that's what we have the XY chart for later. It's just a sketch. All right, here's how I would have thought this through. First of all, the -2, do you get that that moves it to the right a little bit? Okay, next, do you get that this 2 on the outside is a vertical stretch? So that's like I grab it here, that's one hand, here's another hand, and I pull it up. Do you get that that makes my V more narrow? Do you get this is what a vertical stretch would do? It now looks like the green thing. Now, what's this do? First of all, it's horizontal. So it's going to either squish it together this way, like this, or it's going to pull it apart this way and this. So this is a horizontal thing. It seems like it's going to make it 3 times wider. So it doesn't. Get what I'm saying? Counterintuitive. So if it seems 3 times wider, it's actually 3 times narrower. So that also makes this narrower. Do you get this is going to be a super pointy little V in here? That's what I think it should look like. That's how you should start your problems. Then, XY chart it. Find me a few points that are on this graph for sure. Because you check the XY chart and you know they're there. It is so powerful to use an XY chart. It's so useful in pre-calc, even in calculus. Having a little chart like that, you can, if you're lost in a graph, just find a few points, connect the dots. I found a good one. Worked out nice. Yes, sir. You put in 2, and that was smart because it made the middle negative, which ends up, or not negative, made the middle 0. And then, so what's the answer? Exactly. 2 comma 0. Raise your hand if you had 2 comma 0. Awesome. And that's this point right here. So far, I was right. But now I'm going to get exact dots to know for sure where this thing is. Okay. So let's check over here. CG. Give me a point. I'm going to check you. Putting in a 0. That's -2 times 3 makes -6. Absolute value of -6 is 6. Times 2 is 12. Raise your hand if you had 0, 12 on your list. You were right. Awesome. Over 0, up 12. So basically, it's way up here. Does that make sense for my picture? Yeah, it kind of does. Okay. And if I've tried 2 and I've tried 0, what's another logical thing to try for x? 1 and maybe 3. Okay. So let's put in a 1. If I put in a 1, I get -2 times 3 is -6. Makes it absolute value is 6 times 2 is 12. That's kind of cool. Something went wrong, though. I think I just did something wrong. Sorry. I'm going to try again. I'm going to put in +1, and I'd have -2 times 3 is -6. Absolute value of that is +6. I got to clean this up. I can't see. Okay. I'm putting in a 1. Oh, different color. 1. There we go. Thanks for your patience. 1 minus 2 is -1. 3 times -1 is -3. Absolute value of that is 3. 3 times 2 is 6. There we go. 1 gives me 6. Over 1 up 6. That actually works even better. There we go. My side of my V is now shaping up. And then maybe if I put in 3, can you guys save me some time? What did you get when you put in 3? 3 gave you 6 again, which makes sense. I'll go over 1 more this way. It's going to go up 6 just like the last one went up 6. And It's a V, kind of where I said. This was just my sketch. Would I have gotten credit for a sketch? Nope. I would have had to get the dots anyways. But okay, are you getting the idea on the graphing ones? Okay, I'm not that worried about you on the graphing ones. As long as you can know what the shape looks like, know which way the flips and stretches go and stuff. Here's the kind I'm more worried about you on. So we haven't done that many of these. That's why I'm doing them now. What if I give you a picture, like one of my favorite little shapes is like baseball cap. That's f of x. We don't know a function for that looks like a baseball cap, do we? So we just call it random function, f of x. What if I say, take f of x and do this to it? Would you graph what you think the answer is? So you're saying, Mr. Server, I don't know what the function is, but I'm supposed to do -1 on the inside and +4 on the outside to it. If I were you, what I'd do is graph the original one. Graph the original one. We usually graph it for you on tests. We'll have it on the test and say, this is the function. Now do this to it. So really, if you just understand what that means, which is move it to the right one, and that up 4, I'm going to make a new one here in blue just so I can keep my original there. I'm going to move it to the right one and up 4. Do you get what I'm talking about? That make sense to you? Okay. Now let's try a different way. What if instead of saying, hey, graph this one, what if they say, hey, what's a name for that one? If red one's f of x, what's the blue one called? Stay with me. Stay focused. It's the end of the day. I'd call the blue one f of x, except I moved it. Where did I move it? I moved it down 2, -2 on the outside, and I moved it to the right one, -1 on the inside. Raise your hand if you had that one right. Awesome. Okay, how about stretching the little baseball hat? Any questions about the one I just did? I saw a couple confused looks, so I'll give it a second. That moved it to the right one and down 2, so I wrote this. Okay, then what if I said take this function f of x and I want you to do this to it? 2 f of x minus 1. Whoa, that'd be too much. Let's just do 2 f of x. Do you get that the thing on the outside is either vertical or it's horizontal, and that most kids are going to know from the high vo thing? So is that 2 horizontal or vertical thing? Vertical. But I bet a lot of people are going to get this wrong. Here's a really common mistake answer. So you're saying, Mr. Server, you want it to be twice vertically, so I'm going to make it go twice as high. You're actually kind of close, but you're not right. How many of you are confident you have this one right? All right, then let me give you a way. By just adding one little piece, I bet a lot of you are going to be confident you can do it right. All right. I'm going to pause for a second. All right, here we go. So if I do this to it, and only 2 kids in the room seem confident that they could do it right, let me show you all how to do it, so pay attention. Would you agree that this is the point 1, 2? Then think this through. It's on the outside. That's a vertical thing. Is it going to make the x change or the y change? Which the y one is the vertical one. Y is vertical. So it's the 2 that's going to change. So it's 1 comma 2 changes to, come on, think it through, 1 comma 4. Does that make sense to you? Now, it got doubled. It used to have a height of 2. Now it has a height of 4. Think of it that way. Okay, how about this point right here? That used to be the point 3 comma 2. What part changes, the x or the y? The y, and it now is going to be 3 comma 4, right there. And this point, which used to be the point 5 comma 2, now has changed to 5 comma 4. And then how about the top of the hat? Where did the top of the hat used to be? 2 comma 3. So which part gets doubled? Both parts? No. We didn't put a 2 on the inside and the outside. We just put a 2 on the outside. So 2 comma 3 turns into what? Does the x change or the y change? Y changes. So it's 2 comma 6. So here's my last point. Here's my new picture. It's moved up and the hat is taller. Is it any wider than it used to be? No. It would have been if we'd have put the 2 somewhere else. Then that would have affected its width. All right, I'm going to clear this back to the normal picture. And I want to do another one like that because you guys weren't very good at that. So let's try something else like that. Let's make it 1/2 f of x. Now, by putting it on the outside, that's a vertical on the outside thing. That is a vertical change. Horizontally, the hat will be the same width. Try to find where is the picture now. If you're scared for the test, if it was tomorrow, you should be scared. But it's not. We have time. We can still learn this. Pausing. Whoever did. Who got me? All right, good. Thank you. I'm going to move this point down here. Notice its width did not change. Its height changed because it's a vertical thing. So it went from 1 comma 2 to 1 comma 1. This was at 1 comma 2. The new point, 1 comma 1. I'll make the new points green. Okay. Do I have to do that to every single point? It'd probably be the best way to do it. But if I wanted to kind of fake it, I could go like that and be wrong. What part did I mess up? The top of the hat. Because do you see the top of the hat is up 2 where it used to be up 3? And that's not the ratio we wanted. We wanted it to be half as tall as it was. So it shouldn't have gone up that high. So I didn't do it right. I should really do it point by point. So 2 comma 3 turns into 2 comma 1.5, which is right there. 3 comma 2, which was here, is now going to be 3 comma 1. So bottom line, it's kind of very short now. In fact, how short is it? It's half as tall as it used to be. The hat is half as tall. How wide is the hat compared to what it used to be? Same width. All right, good. Okay, would you right now try to make this last picture? I'm going to put a 3 out front and a 1 in the middle. So the little hat has to move and get stretched. Okay, so here's our homework, and it is called Stretches and Shrinks B. It's the last normal homework assignment. Here's the ones I think you wouldn't need to do. C and D. Hold on a second. Let me get this thing going. CD, I'll try to make it simple because the next ones we're going to skip are also C and D. All right. This is your test. You guys are the ones that have to take this test. All right? If you decide to not do your homework tonight, you're taking a big risk because tomorrow is one more review day, but you're putting it all on one day. I strongly recommend you do your homework. All right, down in here, the very last page, why don't you also, besides the C's and D's, skip the last two. That should be easy to remember. Now, this kind is one I would especially pay close attention to, these kind. We'll talk about them more tomorrow, but the last two questions that I suggest you do, you got to write an equation for this. And the tricky part is, it's been stretched. And you got to figure out what is the stretch. I know it's been flipped, that's easy. This is y equals x squared, and it's been flipped upside down, negative. And it's also been moved to the right, easy. I know how to say move to the right 3 and up 7, that's easy. But the stretch factor, that part's hard. Okay, so anyway, that's your homework for tonight. And that's all I got for you for today.